Python's most popular numerical and data science libraries make use of a concept called vectorized operations. These give you the ability to write concise expressions that carry out operations over large amounts of data, either stored in column or table formats. In order to understand vectorized operations, there are two big ideas. First, we need to understand operator overloading and look at how we can design classes that have redefined meanings for operators such as multiplication or addition or concatenation. And second, we need to understand that when these libraries actually implement this functionality, they're going to do so in a different way than we will see in this video. That's beyond the scope of our concerns in this course. They're going to use a lower level, faster programming language that's much more tedious and difficult to write programs in, called the C language. So that's beyond our concerns, but the second thing we need to know about vectorized operations is that they're very fast when you use the built-in or the library's built-in functionalities. So our implementations will be a little bit slower, but they'll help you understand how it is that vectorized operations come together. So let's take a look at what we mean by this at all with a couple of conceptual examples, and then we'll dive into code and implement this together. Rather than thinking about numerical arrays or columns of data, let's focus on like string arrays and think about what vectorized operations might we want to be able to have on string arrays and how might we want to express these concepts. So imagine we're writing a class called StrArray, whose purpose is to provide sort of a level of abstraction or some additional operations that we think would be useful in our program for working with lists of strings effectively. So imagine our first string array, S, is the variable that's assigned a new string array object, and the string array is going to keep track of a list of its values, and this would be the list of strings ABC. Similarly with T, you can imagine we've got a string array where we've got the values DEF stored in its values. What are the types of operations we would like to carry out? Well, we're going to implement two operations here that we can think of as very similar to a vectorized operation. First, we would want to be able to add these two string arrays together. So what is S plus T? Right? So S added to T or concatenated with T, what is this going to mean or result in? Well, for our purposes, I'm going to claim that what we'd like to do is concatenate each of these StrArrays, each of the items in the StrArrays one by one or item-wise, so that our resulting StrArray is going to have the values AD followed by BE followed by CF. Right? So you can imagine this operation that we're applying here as a vectorized operation. Notice we're not writing our own loop to carry out this operation. We're saying, hey, we're going to depend upon a built-in operator overload that the StrArray class has defined in it for the addition operator, or in this case, we can think of as the concatenation operator. And what it's going to do is it's going to produce a brand new StrArray. It's not going to modify or mutate either S or T, but the evaluation of S plus T is going to result in a brand new StrArray where each item is the concatenation of the items in the input arrays. So notice, AD is the same as A concatenated with D, and that's what led to the first item in this list, and so on. So that might be one operator we would like to be able to use, or operation we would like to be able to carry out with this addition sign. What if we also wanted to make it possible to say something like, S plus and then exclamation point? So notice that T's type was a StrArray. So we're adding a StrArray to a StrArray. Well, what if we wanted to be able to add a string or concatenate a string to a StrArray? What would this result in if we evaluated it? Well, we'd like for this behavior to be very similar, but if we think about it deeply, and when we go to implement this ourselves, it's going to be a little bit different. This would be a StrArray where the first element would be a exclamation point, the second item would be B exclamation point, and the third item would be C exclamation point. And notice that we've got two different uses of the same operator. this is part of the meaning in operator overloading, is we're overloading our own meaning in intent to this operation. We're going to be able to define that as the people who are inventing this StrArray class. The other thing worth noting is that there is a difference in behavior here. Here we're bringing two StrArrays together to produce a new one and concatenating each item item-wise. Here we're concatenating a single string to all of the items, or we're broadcasting that out to each of the items. These two types of operations, where you're bringing two arrays together, or you're bringing one array together with a single value and applying that single value in this operation to every item, are very common. And you'll see this in popular libraries such as Numpy, but in terms of numerical operations. So how do we actually go and implement this? Well, let's start from scratch and work this up together. And I would encourage you to follow along with me here. So in my lessons directory, I'm going to create a new file named ls23 underscore StrArray.py. And I've actually already got that file. So I'm going to open that up on my side, and I'm going to delete all this. All right, we're going to bring this to fruition together. So one of the first things that we should do is add a docstring, and this is going to be examples of vectorized operations on StrArray. All right, and we're going to define a class named StrArray. And just like we've discussed, we should the StrArray's purpose is to keep track of a list of string values. So it's going to have a values attribute, and that values attribute is going to be a list of string values that we will initialize as part of the constructor definition. So I'm going to call this a utility class, or I'm going to describe this with a docstring as a utility class for common string operation. So we're thinking about a StrArray as a column of strings that we could imagine being in some larger table of data. And we'd really like to have the ability for our purposes to be able to concatenate to a string array in the way we just looked at previously. So we've got a values attribute. Now, what do? Well, we need to define a constructor. Your classes are almost always going to have constructors that make it easier to initialize the values that you're working with. So if we define a constructor in Python, we're going to name this sort of special method, is one way of thinking about it, init, and it's going to get a reference to self. And we're going to make it possible to pass in values directly to your StrArray. Just like we saw here, this is a constructor call to the class named StrArray. And we want to be able to pass in a list of values. So our parameter here, by convention, I'll name the same as my attributes of values as a list of strs. And this constructor is simply going to assign to the values attribute the values parameter. Right? Great. So now I'm going to, in my global scope, and just for demonstration purposes, as I'm developing this, add some examples of how we might use it. So I can keep this all on one screen. So let's go ahead and say we've got a value that is, say, s. And if I wanted to be very specific about my types, I could say s is a type StrArray, and it's going to be assigned the reference that is created when we construct a new StrArray object. And let's say the list of values is the string A, the string B, and the string C. Right? And for good measure, I can also set up T, and I'll do so using implicit typing. So I'm not going to explicitly type T. T is going to be assigned StrArray, where the values are initially D, E, and F, just like in our starting example. Now, if I wanted to print S, as you know, having studied classes for a little bit here, we're going to have some problems. We're not going to get back useful information because we haven't declared a special method in our StrArray class that tells Python, hey, here's how you represent this object as a string. But let's go ahead and convince ourselves that that is the case here. So I'm going to open up my terminal, and I'm going to run Python 3 with my module lessons.ls23 StrArray as the module. And sure enough, what we see as the output here is the StrArray object is stored at some memory address And now we should make it a little bit more legible what it is, which object it is that we just printed out. What is the string representation of this object? So before we get to vectorization, which is what we'll take on next, let's go ahead and add the ability to represent this particular StrArray as a string. So this is going to be a method that returns a string. And all we're going to do for a nice convention here is return an F string where we make what looks like a string that would be a valid constructor call to reproduce this particular object. So StrArray, and then in the parentheses, I'm going to use my templating to say drop in self.values, which is the list of values, and return that string that's generated, right? So notice this is the name of the class, and this is a call, so we're calling the constructor, but this is a string. This is just textual data that will give us a representation of it. But what's going to be nice is when we print s, we expect to get a string that looks a lot like the one we set the object up with, and same if we were to print t, right? So if I were to print s and t and try rerunning this application, what we see are those two arrays objects printed out, right? So this was all just sort of set up to get us to the point of thinking about adding our vectorized operation, which is going to make use of an operator overload. If you want to pause the video here to get caught up, I would encourage you to do so because we're about to add the addition operator overload, which will give us the ability to carry out either of these operations. Because these are such different operations, let's start with one of the two. And maybe I'll start with the simplest of the two, which is what if we wanted to just be able to concatenate a string to each of the items in a string array to produce a brand new string array? What would the signature of the operator overload look like in this instance? So what we learned in a previous video on operator overloads, if we want to make the addition operator work with s and t, and actually before I do this, just to convince ourselves that if we were to print s concatenated with t, we're not only going to have an error in our code editor saying, hey, you haven't added support for this operator yet, we still need to overload it. But if we were to try evaluating this, we would see a very similar error, unsupported types for the addition operator with StrArray and StrArray. But we said we were going to try and make this a simpler version. So let's start with StrArray plus an exclamation point, which is just the string value. And notice we've still got our error here. So let's go and add support for this. We're going to introduce an operator overload for the add method, or for the addition operator through adding the add method. Self is going to be the left-hand side value. So self in this expression would be assigned a reference to the same object s references. And then the second parameter of the add method is going to get the right-hand side. So we're saying, hey, we want to be able to add a StrArray, which is self, by virtue of it being defined in this class, with a string. So what do we want our string to be? Well, let's call our string the right-hand side and say that it's a string. And as we saw in the first example, we want this to return a new StrArray. So we're not going to modify or mutate the object this method is called on. We want to return a brand new one, and we're going to return a string array. Well, what's our implementation going to look like here? Well, if we go back and think about, well, okay, we're trying to introduce this addition operator for a StrArray s with some string. We want to go through and create a new list where each item is the corresponding item in the input list concatenated with whatever the second string was on the right-hand side of our addition operator. So we can turn this into code. We should set up an intermediate variable that will be the list of strings that we're building up. We're not yet going to have a full StrArray object. We can complete our method by constructing that at the very end. But let's go ahead and set up, a list of our resulting strings, which is going to be a list of str, and it will initially be empty. Right? What we're going to do with that result is fill it by iterating through each of the values in our values list. So for item in self.values, right? So self again is going to be the s object. in this particular statement. So that's going to be the object whose items are the strings A, B, and C. So item would first be the string A. And what do we want to do? Well, we want to append this value. So we want to append item concatenated with the right-hand side, right? And so the RHS in this evaluation of the magic method add, which is our operator overload for addition, is going to be this exclamation point string, right? So item concatenated with the right-hand side would be, for the first item, A concatenated with exclamation point. Once we've completed that for in loop, we know that we've iterated through all of the values in our list. So we can go ahead and return a StrArray object. We can call the constructor, and we're going to initialize its values with this result that we have set up here. All right, great. Now we've got a problem. You'll notice that we can't use the StrArray as a return type. And this is something we looked at in a previous video. We're trying to make use of the class StrArray as a type within the class itself. And it turns out that's a feature that is coming in Python, and there's beta support for if we, as our very first statement in our program, import from future _surrounding, import annotations. And this is kind of a silly step to have to take, admittedly. It's very surprising to me as a programmer and a computer scientist that we need to do something special in order to reference the same class name from within itself. But it is the way it is currently in the Python language. But notice that that solved our problem. We're now able to use StrArray as the return type of this add method. This add method is special because it will be called automatically when we evaluate the addition operator, and we have a StrArray on the left-hand side of it. So let's convince ourselves that this is going to work. So I'm going to run this program, and we see, wow, we get back a StrArray that has A exclamation point as the first string, B exclamation point as the second string, and C exclamation point as the third. We could also, write wow as the string. It doesn't have to be a single character. And I could try running this program, and we see that, oh, we are overloading the addition operator for the StrArray class and all objects of its type, such that if you use the addition operator with a single string, we'll append that string to all of the items and give you back a new StrArray that has those as its values. This is what we think of as the semantics of a vectorized operation. Right? So we're applying this operation to the entire, what we think of as a vector, and that's just another name for array or list. We're doing this in Python code. Most libraries that are very popular would implement this in a more sophisticated way that would give you a little bit more speed, but is the exact same idea at the end of the day. What we're trying to emphasize in this video is what is the conceptual, how does this work at a conceptual level? And if you wanted to create some similar capabilities on your own, how would you go about doing it? So that completes one of our use cases for this add method. What if we wanted to add support for the other use case where we have a StrArray added to a StrArray? Well, we know that in Python, we can only have one add method defined in a class StrArray. So we're going to need to make this, the parameters of this method more broadly applicable. Specifically, we need to be able to say this right-hand side of the addition operator can either be a string or a StrArray. And in order to do that, we need to use a special kind of type. It's called a union type, where we have a union of two different types or two or more types. We talked about unions in the previous video, so I'd encourage you to go back and watch that if you're uncomfortable with the idea of a union. But we'll talk about it here briefly as well. So from typing, which is the typing library that allows us to specify some of these more advanced types, such as union, we will import the union type. Right? Now we can say the right-hand side is going to be the union. Let me try and get that all on one screen. The right-hand side parameter of our addition method is going to be the union of a string and a StrArray. Right? Notice though that by introducing this union, we've actually created an error in our code because we have a problem. This plus operator, the concatenation operator, says, hey, you can't add a string to a string array, right? RHS might be a string array or it might be a string. This logic really only worked when the right-hand side was a string, right? We need to have different logic for when it's a string array. And again, the motivation for this is when we did S plus T, where we added two string arrays together, notice we needed to go item by item through each of the items in those lists. So we need to determine, are we dealing with a string or a string array? And in order to do that in Python, we will use the isinstance function that's built in to test if the RHS is an instance, so isinstance RHS, and then we could say if it's an instance of string, this is what we want you to do. And I'm going to go ahead and tab in this, select all of my text and indent it so that all of this belongs to the then block of this if statement. Alternatively, else. And here we can use an else because we're saying there's only two valid options, right? It's either got to be a string or a string array for this to be a valid function call. So we don't need to do like an else if isinstance RHS StrArray. But if you had 3 or 4 more types that were possible in a union, you would need to be more careful here. Right? But since there's only 2 options, we can use an if and an else. So in the else branch, we know that we're dealing with a StrArray. Well, we can do something very similar, and we'll clean this up and improve it in just a moment, but we're going to have a list of strings that we're trying to build up. And now what we need to do is be very careful, right? And in fact, before we even worry about setting up a list of strings, one of the things we should probably do is convince ourselves that there are the exact same number of strings in the left-hand side of this expression, which is the self parameter, and the right-hand side, right? This worked out because there were 3 strings in S and 3 strings in T. So we wind up having 3 strings total. But if one of these had 3 and the other had 4, we should probably do something about it. What we're going to do is we're just going to use the assert keyword to say assert length of self.values is equal to the length of RHS.values. And you'll notice that we can say RHS.values, and we can even hover our mouse over this. And in VS Code, it'll tell us that RHS is in fact a string array, because we know that at this point, if RHS was not a string and we're in this else branch, in the else branch, RHS is definitely a StrArray. So we're going to test the length of the values of the left-hand side against the values on the right-hand side and make sure they're the same length. What this assert statement is going to do is if this is false, the program will crash and there will be an error. And we can try that out in just a moment. Okay, but if they are the same, it effectively has no impact. We're going to continue on to the next line, and that's okay. So we're instituting a check here, where in more advanced programming classes, you would learn other ways of handling this potential error. Here, we're going to be okay with the idea of just crashing the program if you call this particular method, or if you use addition between 2 StrArrays that have different lengths. All right, so now what do we do? Well, let's go ahead and loop through each item in both arrays. Now this is a place where you need to be careful. We can't use your traditional for item in loop. What we should do is use indexing, right? Because we want to access index 0 of S the same time we access index 0 of T. We want to access index 1 of S the same time as we want to access index 1 of T. Because ultimately we're taking those 2 values and concatenating them together. So how do we use a for loop to iterate through the indices of a given list? Well, I'm going to use for I in a range where we start from 0 and we're going to go up to the length of self.values. Right? So let me break this down because this is an important concept to understand. When the built-in range function is given only a single argument, that means that it's going to start from 0 and count up to but not including whatever argument you give it as the stop value. So the stop value is the length of the number of values we have. So I is going to range from 0 to, in this case, 2, because 0, 1, 2 are the number of, are the indices in our list, and we're going to stop there. So what are we going to do for each I? Well, we're going to append to result, so result.append, and we're trying to append self.values at index I, concatenated with RHS.values at index I, right? So let's break this expression down. Self.values is the list of values. So for S, this is this list ABC. And I is going to start from 0, which would be, self.values 0 would be A. And we're going to concatenate that with whatever the right-hand side is. So in order for this method to call, we would need to print, S concatenated with T here, S add operator T. Now there's one more step that we need to carry out here, which is we need to actually return a StrArray. We can see that, hey, there's this error here that says, hey, there's a code path that doesn't result in a return. So I can return StrArray with our result as the initial list of values. And now we've implemented this add method such that we've got an operator overload where we can, concatenate a single string with all items in a StrArray, or concatenate all items in a StrArray of the same length as another StrArray with one another. So let's convince ourselves that this works. And if I were to clear my output and run this program one more time, we see the expected output for the first one. And then for the second addition operator, notice that we're seeing, the first item has, the A from the S StrArray concatenated with the D from the T StrArray. And that checks out. So there are a few things that we should do. First, we should test this assert statement. As I mentioned, the expectation is if, let's say, T has an extra item in it, so D, E, F, G. So T's length of values is going to be 4, whereas S's is 3. What we expect to happen is this program is going to crash when it tries to evaluate this particular expression. And we see that there's an assertion error. The assertion that failed was, this line right here, line 25. And if we were to look at this error, we would see, this happened at line 25 that was called from this print S plus T line, which was line 35. So we can look at this error to see where in our program it occurred from. And now we know that the reason was because we misused this addition operator. If you want to use this vectorized addition operator with StrArray, we need to give 2 StrArrays of the same length. One other improvement we should make is there's some duplication happening here. Notice that we have these 2 branches and they have shared lines. So this is the same line, setting up an empty list of strings as our result. And then this return statement is also the same between them. So what I'm about to do next is what's called refactoring, which is sort of reorganizing some code, not to have it have any different effect or behavior. In fact, we're trying to keep the same behavior, but we're trying to clean up and make our code a little bit less redundant so that there's not this duplication here. So we notice that, setting up this empty array is kind of the first thing that happens in either of these 2 branches. It doesn't necessarily happen first in the else branch, but this is kind of a no-op, or that's short for no operation. It doesn't really do anything in the case where we don't error out. So we can think of these as sort of, it doesn't really matter. We could have achieved the same thing by placing the result line just above that. And this could have been the first operation in our else branch. So if this is the case, then we can move this initialization statement from inside of our if statement to above it. So that's the first thing I'm going to do. And I'm going to remove that statement then from both of my branches. So notice this was a simple refactoring. I took one line that was shared between these 2 branches at the very top of them and moved it above it. So now in both cases, we're going to set up an empty array in the result variable. And similarly, we have this return statement. And notice that the return statement is happening at the very end of both of these branches. So what if we moved the return statement to follow the if else? So I'm going to move my second return statement to be on the line after and then unindent by 1. And then I can delete the return statement in my then branch. And so notice that now we have only one line that is result is initialized to an empty list, and one line that is return a string array with our result as the values that it uses. So in a sense, we've deduplicated these lines of code, and our logic is a little bit simpler and cleaner. When the add method is evaluated, because we use the addition operator on a StrArray object, we'll first set up an empty list, and then we'll test, hey, what was the right-hand side? If you gave me just a string, I'm going to do one thing. I'm going to append that string to all items and give you back, ultimately, a StrArray with those items. If you gave me another StrArray, first I'm going to make sure you did this right, and you gave me two StrArrays with the same length of values. And then I'm going to iterate through each index and concatenate the items at those indices together. Right? And this is pretty neat. Now we have, notice, in our actual usage code. So once we have this class defined, whenever we want to go and work with StrArrays, if we had a big column of 100,000, a million different strings of, say, like someone's first name and someone's last names, and these are two different columns, and we wanted to bring them together. So for example, we could set up a first name StrArray where I've got my first name and Kaki's first name. You could imagine more. You should add yours in there. And a last name string array. We think of these as columns of data. So Jordan and Ryan, add your last name in. How can we get a full name string array or a single column with these two names brought together and say maybe a comma between the last name and the first name? So last name first, first name second. So I could say full name is the result of last concatenated with the string comma space concatenated with first. And we could print full name. And notice we're doing this with two names. If we wanted to add a third name, we could add a name like Michael Jordan. And you could add your own. We could have plenty of names here. There could be hundreds of thousands of names in our StrArray if we were reading this from a data set. What's really cool and very powerful about vectorized operations is look at this expression. We're saying take all the names in the last name StrArray and concatenate a comma and a space to each of them. And this is going to result in a new string array. Because these two addition operators are at the same order of precedence, this expression is going to evaluate first. It's as if we have a set of parentheses around it. We don't have to have those parentheses though, so I'm going to take them away. But this addition operator is going to result in a StrArray. And so a StrArray with the addition operator followed by another StrArray is then going to take the results of this first operation and apply concatenation with this other list of names and bring those all together. If you were to try and carry this out without operator overloads in vectorized operations, think about the loop that you would have to write in order to make this work, and think about having to make your own list and append to it and all the extra steps that would be involved, and how much more concise and expressive it is once you understand this is how it works to be able to write an expression like this. And that's really the beauty of vectorized operations. So let's convince ourselves that this works and try evaluating this example. And notice that we get a StrArray where the first string is Jordan, comma Chris, the second string is Ryan, comma Kaki, and the third is Jordan, comma Michael. If we wanted to convince ourselves that this was, very flexible, we could say first plus, and then maybe the string slash concatenated with last, right? And we try this again, and Chris slash Jordan, Kaki slash Ryan, Michael slash Jordan. Pausing to really reflect on what is the work that's happening for this to evaluate. And thinking about, well, oh, this add method is getting called twice. It's getting called the first time right here, and then that result is going to be evaluated and added to using the same method, the last. So if we wanted to, we could print out as this add method, print add was called. And if we wanted to, we could even be a little bit more specific here to give us a sense of, what is what is being added. So self and RHS. Right. So each time this add method is being called, and notice that in our code down here, we don't have any explicit method calls to it, but we know that using this addition operator is what ultimately causes this add special method to be evaluated. So I'm going to clear this and try evaluating this. And what we see is, there's quite a bit of, each time the add method was called, we get this print statement that says add, and then we see we're adding ABC with the string wow. And then we're adding the string array ABC with the string array DEF, and that's resulting in, the string array where it's AD, BE, CF. And then when we get down to this last example that we were just looking at, where our first name is being added with the slash string, we see this is the first call to add, where we have, the strt array with Chris, Khaki, Michael, and the slash string. And what are we adding? What's the second call there? Well, this second addition operator is given the result of the first addition operator, so Chris slash, Khaki slash, Michael slash, as the left-hand side, and then ultimately Jordan, Ryan, Jordan as the right-hand side, and bringing those together. So to complete this example, I'm going to remove that print statement that was just there for pedagogical and debugging purposes. And typically, when we're working on a class like this, you wouldn't want to have, example usage right down below it like we have here. So you could probably, if we were working on a real class, we wouldn't have this here. But for notes and for keeping track of what it was that we did in this example, I would encourage you to play around with this further. So in this video, what we achieved was we achieved what's called vectorization or vectorized operations. We achieved half of vectorized operations. Namely, we implemented them using the same semantics. We implemented a StrArray class where we overloaded the add method so that we could have a vectorized operation adding two StrArrays together or adding a StrArray with a singular string. And that resulted in concatenation operation being applied to each item in either one or both StrArrays. As I mentioned earlier, the other part of vectorized operations in the real libraries like Numpy and Pandas that you'll use for numerical data science, they would implement this same logic, but in a programming language that is a little bit more efficient and faster at the expense of being harder to write. So there's a speed improvement that you get in using a library such as Numpy or Pandas that we won't be able to achieve in plain old Python, but the same ideas apply. And hopefully, now that you have a sense of how it is vectorized operations work with overloaded operators, and you're going to get a chance in the next exercise to work on implementing your own operations like this for a numerical column of values that's very much like the Numpy library. When you go out and you use Numpy and Pandas in real world applications, you'll have a much stronger sense of what's going on behind the scenes and a much more clear mental model for the work that's happening on your behalf. The real benefit of this at the end of the day is being able to write these concise expressions that don't operate on, just one string value and another string value, but that apply this operation to entire columns of large data sets of values at a given time so that we can write simple expressions that have very powerful, robust applications. Great work moving through this video, and I hope that you enjoy using vectorized operations in the future.